In this first part of our code, we import the necessary components from Three.js, which is a popular JavaScript library for rendering 3D graphics in a web browser. We import the core functionalities from the Three package and a specific GLTF loader module which allows us to load 3D models in the GLTF format. Here we're setting up the essential elements of any Three.js application. We create a new scene, which is where all of our 3D objects will live. We define a perspective camera that mimics the way the human eye sees. It has a 75-degree field of view and aspect ratio based on the browser's window size. Finally, we create a WebGL renderer, which uses hardware acceleration to draw our scenes efficiently. We set the renderer to the full size of our browser window and append its canvas element to the document's body. This canvas is where our 3D scene will be rendered. Good lighting is crucial for 3D scenes. We add an ambient light to provide soft, omnidirectional light, and then a directional light simulating sunlight. We position this directional light to shine from a certain angle and normalize it, which means it's a unit vector pointing in this specific direction. We position our camera within the scene at a distance of 5 units along the z-axis. This ensures there is some space between the camera and any objects we might place in our scene. Now, let's load our 3D model. We create a new instance of the GLTF loader, which can load models in the GLTF format. We initiate a load operation by providing a path to our model. Once loaded, we add the 3D model to our scene. After the model is loaded, we create an animation mixer, crucial for managing animations. We then retrieve the first animation from our GLTF model and create an animation action. We set it to loop repeatedly and then play it. We also provide a function to handle any errors that might occur during the model loading process. Next, we set up the animation loop, which is the heart of any real-time rendering application. We create a clock to keep track of the elapsed time and define the animate function. Inside this function, we use requestAnimationFrame to call animate recursively to form a loop. Within our animate function, we check if the mixer has been initialized. If it has, we calculate the time elapsed since the last frame and call the mixer's update method with this delta time. This updates our model's animation. Then, we render our scene using the previously defined camera. After setting up these pieces, we start the loop by calling animate for the first time.